Alright, now we're going to carry it one step farther here with our graphing. Notice these videos are going, we're edging a little closer each and every time. So now these first two methods that we learned, we're going to combine them and learn what it's like to graph something in either of these forms. This is a combination of the first two videos you've seen. So, little review. Remember, to find the amplitude, that's the absolute value of A. The period is 2 pi over B. 2 pi over B. Now remember, if B is greater than 1, the graph is going to be compressed horizontally. If B is between 0 and 1, then it's going to be stretched horizontally. Okay, so we learned that in the last two videos. Now we're going to combine this all into one now. So here's what I want to do. I want to graph y equals 3 cosine of 2x and let's graph it on this interval. Let's graph it on this interval. So from negative pi to 2 pi. Negative pi to 2 pi. Alright, so first of all, what's the amplitude? Well, the amplitude is the absolute value of 3, which is 3. So that means when you get ready to start doing this, the largest number, as of right now there are some exceptions to this rule that we'll get to when we add our k value, but the largest number here that you'll have in your graph is going to be 3 units from 0. Okay, so 3 and negative 3. Okay, so here's our period. Our period is 2 pi divided by b. B in this case is 2. So our period is pi. Now, we have something that we haven't had to consider so far. Normally, we've had basic sine and cosine graphs. And so we really haven't had to consider something called an increment. Okay? Something called an increment. And basically what the increment is the period divided by 4. Okay? So essentially what we're doing is we're taking our period and we're dividing it into 4 equal parts. So this is the increment is what you're going to use to help scale your graph. So what is the increment for this? The increment is pi over 4. So that means our scale is going to go up by pi over 4s. Alright, so let's draw. We know that our amplitude is 3, so it's going to go 3 units north and south. Okay, so that takes care of the amplitude. And we know that this is 0, and we're going to go from negative pi to 2 pi. So I'm going to do the positive ones first. So we're going to go every pi over 4. That's our increment. The increment's going to help you scale this. So this would be pi over 2. Pi over 4 plus pi over 4 is pi over 2. Then you're going to have add another pi over 4. Okay? Then you're going to have pi. What is this one at, by the way? This is 3 pi over 4, right? 3 pi over 4. This will help you learn your unit circle as well. Alright, we have pi, which is 4 pi over 4. 5 pi over 4. 6 pi over 4, which is 3 pi over 2. 7 pi over 4. And 8 pi over 4, which is 2 pi. Now this is scaling our graph by pi over 4. That's what that increment is. Alright, now we have to go to negative pi, so this is going to be a negative pi over 4, a negative pi over 2. That's why I do the positive side first, because it's going to help you get this side a little easier. This is negative 3 pi over 4, and this is negative pi. Okay, so here's our graph, okay? And we know from 0 to pi is one cycle, because pi is our period. So 0 to pi is one cycle. So watch what I'm going to do. I'm going to draw myself a t-chart. I'm going to draw myself a t-chart. So I've got 0, and we're going up by pi over 4, remember, because of our increment. So this is going to be pi over 4. This is going to be pi over 2. This is going to be 3 pi over 4. And this is going to be pi. Now you can continue and you can do the negative side and all the way up to pi over 2. But here's why I wouldn't do that. Because remember, this is a wave. This is, after the first period, we're just restarting the wave over again. So once you get one period, you should, in theory, be able to get the rest of these. Okay? So for instance, take 0, plug it into our original equation. So this is 3 times the cosine of 0. Now what is the cosine of 0? The cosine of 0 is 1, right? Cosine is the x-coordinate. Look at your unit circle. The cosine of 0 is 1. So 1 times 3 is going to give me 3. Okay? Pi over 4. What's the cosine? Now this is, remember, this is 3 times the cosine of 2 times pi over 4. I know this is a little sloppy, bear with me. 2 times pi over 4. Well, what's 2 times pi over 4? That is really pi over 2. 2 pi over 4 is the same thing as pi over 2. So what's the cosine of pi over 2? Well, the cosine of pi over 2 is 0. And so 0 times 3 gives us 0. Okay? Now go ahead and plug pi over 2 in. And what you're going to get is pi over, the 2 times pi over 2 is just pi. So you've got the cosine of pi, which is negative 1. And 3 times negative 1 is negative 3. I just didn't write it out that time, but I'm doing the same method. I'm just plugging, just like you would if you were to graph an equation in algebra. I'm plugging into the function and getting my answer. Okay? What about 3 pi over 4? 3 pi over 4. Well, that's going to give us 0. And what about pi? Well, the cosine of 2 times pi, which would be 2 pi, the cosine of 2 pi is 1. 1 times 3 is 3. So this is what it looks like over one interval. Over one interval. So now, what can we do about that? Once you come up here to your graph, I know it's 0, 3. I know it's pi over 4, 0. Let me do a different color so you can see that. 0, 3. Pi over 4, 0. This is going to be pi over 2, negative 3. This is going to be 3 pi over 4, 0. And this is going to be pi 3. Now, you should be able to figure the rest of them out from this. So where's the next one going to go? Well, follow the points. This is going to go down. 5 pi over 4 would be 0. Then we go down to 3 pi over 2, which would be at negative 3. Back up to 0 again. Just like this. Okay? Now, be careful going the opposite direction, because remember, you're going You're going down this time in a different direction, but we're still going down to 0. Negative pi over 2 would be negative 3. Back up to 0. And negative pi would be 3. Negative pi would be 3. So you should be able to get your points from that initial interval, and now you can take your pencil and you should be able to successfully draw this cosine curve. Like so. Alright, so we successfully drew the cosine curve. Okay? So this is what I'm talking about when even though we may only be able to assess parts of it online, I'm not going to be, due to the online format, I'm going to have to ask you questions to get answers. It's going to be hard for me to actually get you to graph the whole thing at one time. I'm going to try my best to. I've tried my best to select. There are some questions that will ask you to, but for the most part, it's going to ask you parts of it. So here's what I'm going to need you to do. I'm going to have some problems for you so that you can be practicing this. You're going to need to practice graphing this because this is what a question will look like on your exam. I'm going to give you the equation. You're going to have to tell me the amplitude, the period, the increment, and soon enough, the vertical shift, things like that. And then, first and foremost, you're going to have to be able to graph it for me, just like I did here. You're going to have to reproduce this by hand. Even though we may not get to assess it that way online, I'm going to expect you to be able to plot these points and graph it. Now, there are a few questions that you're going to have to graph it just to know what you're looking at, okay? So you will have a few exposures to graphing the full thing. But the only other exposures will be the problems I assign you, from the book. And so you're going to need to do those in your spare time. And if you have questions, please do not hesitate to ask, okay? But this is how you graph a cosine function with A and with B. Okay, so let's look at another one. Let's look this time at this one. Let's look at y equals -1/2 sine of pi x over 2. And we're going to graph the equation on this interval. Now notice the interval. The interval here is not, notice the interval. It's not in radians, is it? Well, it is, but it just doesn't look like it because there are not any pi's there. What happened to the pi's? Hold on, we'll see. Okay, so what is our amplitude? Well, our amplitude is the absolute value of -1/2. So our amplitude is 1/2. Okay, our amplitude is 1/2. Alright, so what about our period? Well, the period is 2 pi divided by b. Now, what is your b here? Hopefully, you're screaming at the computer, pi over 2. The b is pi over 2 here. So notice what happens. This is 2 pi times 2 over pi when you multiply by the reciprocal. So our pi's here cancel, leaving us with 4. That is why we do not have pi in our interval up there. The pi's canceled each other out. So what is my increment? Well, it's the period divided by 4. So 4 divided by 4. So I'm going to scale my graph, my x-axis at 1. I'm going to scale my x-axis at 1. Alright, so draw your graph. Now the scales on the graph, these graphs on the axes do not necessarily have to be the same. Okay? This is not like algebra where we want it to be the same. Some of the scaling will be a little different just to make your point, and it's fine if you do that, okay? It's fine if you do that. So we're starting at 0. My increment's 1, so I'm going to go 1, 2, 3, 4. But remember, I'm going up to 5, so I have to do 5. And then I'm going to go backwards. Now this is -1, -2, -3, -4, -5. Now, how am I going to mark my y-axis? Remember to look at your amplitude. So this tells me that my amplitude is going to be 1/2 units away. So my largest point is going to be 1/2 and -1/2 on the y-axis. Okay? Now, this will be different, like I said, when we add the k value in there in our next video. The next video is when we'll start adding the vertical shift to it. Okay? So, bear with me for now. We will get to that here in just a moment. Alright, so for this particular problem, make your t-chart, x, y, and I know I told you could go one period, and that's what I did. That's one period right there, 0 to 4. Okay, 0 to 4 would be one period. But what I'm going to do is I'm going to go ahead and do 5 while I have it here, since there's only one more above our period, and that way it'll make it a little easier when we go back the other direction. Okay, so take 0, plug it in. So essentially what that's going to give us is -1/2 times the sine of pi times 0 over 2. So that gives us the sine of 0. 0 times pi is 0. 0 divided by 2 is 0. So this is -1/2 times the sine of 0. Well, what is the sine of 0? Well, look at your unit circle. Sine of 0 is 0. Sine is the y coordinate at the 0 point, remember, at the 0 angle. So sine of 0 is 0. So -1/2 times 0 is going to give us 0. Okay? All right, so at this point, we have 1. Now, we would be plugging in a 1 right here now. So that's going to give pi times 1, which is pi over 2. So what is the sine of pi over 2? Well, that's +1. And 1 times -1/2 gives us -1/2. Okay? Plug a 2 in right here. Plug a 2 in. Okay? And what that's going to give us is 2 pi over 2, which is just pi after you do your simplification. So what's the sine of pi? Well, the sine of pi is also 0. So 0 times -1/2 gives us 0. All right, so then we do 3. Take your 3, plug it in, and this is actually going to give you a +1/2 when you plug it in and find out its value. It's going to give you the sine of 3 pi over 2, which is -1, and -1 times -1/2 is +1/2. Well, what about when we plug 4 in? You should start seeing the pattern now. When we plug 4 in, 4 is going to be 0. Okay. Now notice we've started over. This is our one period right here. This is officially the whole cycle. So now we've started over. So you can determine that the next one is going to be 0.5, right? Because we've started over our period. So let's plot our points. And so we have 0, 0. We have 1, -1/2. 2, 0. 3, 1/2. 4, 0. and 5, negative 1/2. Now when you're going back the other direction, what is negative 1 going to be? Negative 1 is actually going to be positive 1/2. Now if you're unsure, if you can't see the pattern, hopefully you're seeing the pattern of the problem with the way you've plotted the points. If you can't see the pattern, make a T-chart. Don't miss this because of pride. Make a T-chart and make a T-chart from negative 1 all the way to negative 5. Plug them in for X and get your answer. There's no need in you missing this problem because you can't see the pattern. Some people have difficulty with that. But if you can see the pattern, then you're going to automatically be able to plot this so much easier than you would have been able to if you can't see the pattern. See how quickly I'm plotting that? Because I was able to see the pattern in our graph. Okay, so watch for patterns. Watch for patterns. So now when you get ready to draw this, here's our drawing. And our drawing of our sine function is going to be something like this. Now hopefully you're screaming at your screen because you say, that's not the sine function, Mr. Francis. The sine function, hopefully you've got it memorized by now, looks like this. That's the sine, that's y equals the sine of x. Well, why does this one look different? Well, it's the same function, but notice it's flipped. Why is it flipped? Does anybody know? We didn't talk about this because when you do a T-chart like I show you to do here, it automatically takes that into consideration. When you do a T-chart, you see how we're multiplying by this negative 1/2 when you're finding your points. That automatically takes the flip into consideration, so you don't have to worry about it. That's why I like the T-chart method, because you don't have to worry. But what causes it to flip is this negative sign. It causes our graph to flip. Don't forget that. The negative sign causes it to flip. So that's a graph of A cosine B and A sine BX. That's one of each. Okay. Now, the next time on the next video that you're about to see, it's where we get to the fun part. We actually put K, the constant, in, and this is where we put everything together, and this will be the ultimate sine and cosine graph that you'll have to do.